Why is landing on Mars so difficult?
'Cause trespassing is prohibited on Mars.
Oh, listen. Before Mars, we successfully landed on Earth and Moon. Earth has a thick atmosphere. So, the advantage in this case is that we can use parachutes to slow down the spacecraft. While the disadvantage is that the thick atmosphere creates frictional heating, thus requiring heat shields. Now, as the Moon has no atmosphere, the disadvantage is that parachutes don't work. Hence, we need complex retro rockets. But the advantage is that no atmosphere means no friction, so no need of heat shields. Now, more than 50% of landings on Mars have failed because we face both the above disadvantages here. Why? Because Mars's atmosphere is 100 times thinner than Earth's atmosphere. So, parachutes are ineffective. Hence, we need complex retro rockets. Also, as the atmosphere is not completely absent, we need heat shields. As a result, the complexity of landing on Mars increases. What if the Earth had rings like Saturn?
Then Jupiter would be jealous of both of them.
Oh, some. Earth would have rings if a celestial body like Moon or comet gets too close to it and exceeds the Roche limit. It will get ripped apart into pieces, thus forming its rings. First of all, Earth would look spectacular. Secondly, selfies might be called ringies, as people will start taking selfies with rings as a backdrop. Thirdly, nights would be much brighter than they are now. This is because the rings would be much closer than the Moon and also much more spread apart, thus reflecting much more light. Fourthly, weather patterns or atmospheric composition might change depending upon what the rings are made up of. Saturn's rings are made of billions of particles of ice, rocks, and dust. Lastly, they would surely top the world's best tourist destination list. What if there were no clouds?
No problem. I have my magic carpet.
Some. Firstly, without any clouds, sunsets would no longer look spectacular. Secondly, without any clouds, there would be no way to redistribute fresh water from one place to another. Why? Because no clouds means no rains. Eventually, all the water present on Earth would evaporate and our Earth would begin to look like Mars, dry and barren. Thirdly, temperatures would suddenly rise during daytime and drop at night. Why? This is because clouds help regulate temperature. As clouds are generally white in color, they reflect a good amount of sunlight, thus helping keep our day temperatures down. But at the same time, at night, they don't allow all the heat reflected from Earth to escape, thus not allowing our nights to get too cold. Why is space black? Our sun is a huge star, which emits a tremendous amount of light. However, like our sun, there are so many stars in the universe that counting them is almost impossible. So, if there are so many stars, the space shouldn't be black or dark, right?
Absolutely.
However, this is not the case. According to a study, the space appears black because the universe is expanding. This expansion is causing the visible light emitted by the stars to stretch out so much that when it reaches our eyes, they cannot detect it. As our eyes cannot detect any visible light, the space appears black to us. Moreover, light has a specific speed limit. So, light from far, far away stars has not even reached us. Thus, the space appears black. What if Earth doubled in size?
Wow. Will my burgers also double in size?
Stop it, some. Diameter of Earth would increase from 8,000 miles to 16,000 miles. If the density of Earth remains same, then its mass will increase 8-fold. Earth's gravity will naturally double. This will have major consequences. Firstly, our weight will double. All the gyms will definitely see increased enrollments. Secondly, our bones will not be able to support our increased weight. Thirdly, our hearts will have to work double hard to make sure blood reaches all the parts of our body. Fourthly, birds, airplanes, choppers will all fall down to the ground. Fifthly, trees will not be able to stand upright. Most of them will fall down. Finally, if we fall down, it will hurt twice as much. What if the Earth had 2 moons?
So what? Even I have my 2 lollipops. I lick them every day.
That's gross, Sum. The most obvious effect of 2 moons would be that our nights would be much brighter. That would certainly be bad news for stargazers and astronomers. Also, as you all know, that tides on Earth are a result of the moon. So, 2 moons would either amplify this effect or cancel out each other. If they were to amplify, then we could have huge tides, effectively making living near shorelines almost impossible. But it will definitely be good news for all the surfers. Finally, as the number of moons increases, so will the number of solar eclipses. Also, hypothetically, if they were to ever collide with each other, then the amount of debris coming out of such collision would make living on Earth almost impossible. What if you fell into a black hole?
I'll color it with my colored pencils.
No. Boundary of the black hole is called event horizon. Small black holes have stronger gravitational forces than large ones. If you fell towards a small black hole, the strong gravitational forces would stretch you until you are torn apart, even before you cross the event horizon. In case of a large black hole, you'd be able to enter it unharmed, falling freely until you reach its center or point of singularity. Here, you would get squashed and merge into it. But your friend observing this from outside never actually sees you enter the black hole. He just sees you fall in slow motion, freeze, and then go dimmer. Why? Because our current laws of physics don't apply beyond the event horizon, making it impossible for us to see beyond.
What would happen if you were to bring a tiny piece of the sun to Earth? Short answer, you'd die. Long answer, it depends which piece of the sun. Like most of the matter in the universe, our sun is neither solid, liquid, or gas, but plasma. Plasma is when stuff is so hot that the nuclei and electrons can separate and flow around freely, which creates a goo-like substance. So you can imagine our sun as an extremely big, spherical ocean of very hot goo. The deeper you go, the denser and weirder the goo becomes. What if we go much, much deeper? Last sample, the core. Here in the central 1% of the star, we find a third of the sun's mass. The matter here is compressed by the weight of the entire star above it. In the center of the core, the temperature is 15 million degrees, hot enough to make helium by smashing together hydrogen, powering the sun by nuclear fusion. In billions of years after the death of the sun, this core will remain as a white dwarf. If we brought a sample of it to Earth, it would cause a lot of inconvenience. The biggest nuclear weapon ever detonated had an energy of 40 megatons of TNT, or a cube the size of the Empire State Building. Our sample has the equivalent of 4,000 megatons. This is 4 billion tons of TNT, or a cube 1.3 kilometers high. To give you a sense of scale, this is the cube inside Manhattan. Once the sphere arrives on Earth, this super dense matter expands instantly and creates an explosion with the force of, well, the sun. If we get the sample in Paris in the morning, the citizens of London would see what looks like a second sunrise. but one that gets brighter and brighter and hotter until London burns to ashes. In a radius of about 300 kilometers around the blast, everything would be burnt. The shock wave would travel around the Earth multiple times. Most buildings in Central Europe would be flattened, eardrums would rupture, and windows break across the continent. The explosion would be apocalyptic, possibly human civilization ending. If humans did survive, we could count on the dust blown into the atmosphere to create a small ice age. So, if there is one tiny bright side, it would be that the explosion might be an effective way to control human-caused climate change for a few decades.
What if a black hole entered our solar system?
Don't worry, Sum is ready. I will save everybody.
Wow, Sum. Firstly, black holes' gravity will cause complete chaos in our solar system. Orbits of planets as well as comets will be significantly altered. Initially, comets and meteorites might start hurtling towards us. Later, even the planets might start colliding with each other. Secondly, even if a gigantic planet like Jupiter comes in the path of the black hole, it will be devoured. Thirdly, if the black hole comes near Earth, initially its intense gravitational pull will cause devastating earthquakes and volcanoes. When the black hole reaches our orbit, there will be nothing left but an uninhabitable magma-laden rock. Lastly, our sun might offer some resistance to start with. A gravitational tug-of-war might ensue, but eventually even our beloved sun will be ripped apart to pieces.
Is Mars really red? Am I really human? Ha ha ha! Rocks and soil on Mars mostly contain iron. Here comes atmospheric oxygen! Reacting! Whoa! Reddish iron oxide or rust is formed. So, Mars is red. Huh? Aha! Let's look through the rovers. Whoa! Some areas are brown or green or even butterscotch colored. Then why does it look red? Dust storms! They last for weeks or months. They kick up the rust into the atmosphere, thus giving it a reddish color.